Evening all. Yeah, sorry, I'm fashionably late today. Took me a while to get all my ducks in a row. And we're without Claire this evening as well, because she's currently travelling, so I don't know what we'll get up to. Chaos. It'll be chaos, I'm sure. Hello, hello. So tonight we're going to be looking at better approach distances for the autopilot, and calculating those in a more reliable way, because right now I don't want to say the word bodge, but we're kind of bodging it in terms of working out where the ship should stop. So we'll work that out as an actual vector in space and kind of nail that as a point in space, as opposed to just kind of going for a distance away from target kind of approach. And we'll also try and fix some of the display issues on the holo-display. And what else? And stuff. We're just going to be kind of fixing stuff and optimizing things tonight. I've got 3 pages worth of bugs to fix. In fact, if we have a quick look at the tracker, 131. There's 131 bugs to fix. So we won't get all those done on stream, but lots of bugs that need sorting out. So I'm going to try and clear off some of those tonight. As always, though, let's have a look at what I've been doing over the past couple of days. The funnest of which is I've added a report on our galactic map on the website, so you can now either show vessels by prefix code or just look at all of them, and it will show you all of the ships that we currently have registered. So you can see that one, which I won't even try to pronounce, is almost at Sajay. It's like there's a bit of a Sajay race going on there. But yeah, you can hover over any of those vessels, and if you click on one, it will take you to its vessel profile. What else have I done? I need to check my own notes because I can't remember what's happening from one day to the next otherwise. Oh yeah, so I fixed the ability in game here to enter a description for the ship, and the description you enter here and save will appear immediately on the website. You can also change your prefix code and registry number. One caveat when you do that is the name of the URL that links to the profile takes the registry as kind of like the slug for the URL. So if you change it in game, it will change it here. So this would cease to be accessible. You'd have to either find it on your fleet page or on your profile page to get back to it again. It doesn't go anywhere. It's just that the slug there changes when you update it in game. What else did I do? Oh yeah, and I fixed all the customization as well. So basically, anything in game that requires any of this should now be updating like immediately, and also working in multiplayer. So that's why my ship is kind of weird colors at the moment, because I've been testing it. But yeah, everything seems to be working. It says it there, says it there, says it there, and it'll say it on the back of the ship too, all working. What I was doing just before coming on stream is I wanted to test a bit of code I've been working on in the autopilot code. So what I'm trying to do is work out what's in range of the ship. So we're taking basically taking all of the objects within the current star system, we're adding all of those into an array. And basically we're doing distance, location and radius. We're then sorting that by distance. So we have the closest one's always the first thing in the array. And then on our autopilot, we are delete that. We are trying to get the ship to steer around that object. So this is needed for a couple of reasons. One, to stop the autopilot plowing into stuff, and two, to have the ship stop next to a planet rather than in front of it. And it also plays into some of the arrival distance stuff that we'll be doing tonight. So there's a whole slew of bugs that this should fix. But I've yet to test it, so let's kick off by testing that and see whether it actually works. So I suppose the first thing we need to do is just target something in the system. So if we target that, use target, so it should be somewhere. Okay, so I'm assuming that that's not where it is. Hang on, let me target a different one. Okay, so perhaps it is actually there. And yeah, we are going to definitely plow through the planet still. Okay, so that definitely needs more work. Fine. Didn't think it would work first time. Let's make sure that that's actually being built. Okay, so we're doing sort local objects. Clearing that, grabbing that. Let's just do some output. Yeah, basically, it's doing a dot product on the vector. Hang on, let me grab it. Yeah, so basically we're giving it location of the ship, the desired direction, which is what we're calculating already within the blueprint, so we're just feeding that into the function. And then we're giving it this safety margin, so that's basically the radius of whatever the object is, plus an additional 10%. So we should always kind of steer 10% away from the object radius. And then we're just doing a dot product basically, just to kind of work out the angle. There was I can't remember what it's called now. I think they call it like tangent steering. There was a thing I was looking up that's supposed to do this, but I've yet to get it to work. each one of these, I just want to just make sure we're actually getting the right values. So distance, location, oops, radius. Those can go in like that, and that's going to need to be made into a string. I'll leave it on 1 second because this blueprint should be refreshing once per second. Well, we kind of need to do it by math, because when we're like right next to the object, all we need to know really is which way is the ship facing. That's kind of like that's the fundamental thing, because what we're feeding into the autopilot is make the ship face this certain direction. I think this is actually reading backwards, which doesn't help. But yeah, so we're wanting the ship's going to want to head in a certain direction to get to its target destination, and we're already pre-computing what that destination is. What we need to work out is there a planet in the way, or is there another object in the way? So it could be a planet, a moon, or anything else. So the point of doing it like this is we take the desired direction that we want to fly in, work out if it hits something, and if it does, then we basically give it a tangent so it steers away from the radius of that object. So this is updating at 30 times per second. So it's constantly adjusting the nose of the ship to face 10% beyond the radius of the object that we're in front of, which will cause it to smoothly steer around that object until there's a clear path to the target destination. So we don't need to draw a path or compute a spline or anything like that. All we're doing is basically working out, are we going to hit something, yes or no? And because we've got the object location and radius as our two inputs, then we can do the math on that, so we know whether or not we're going to intersect with that sphere. Obviously that only really works for spherical objects, but it needs to be quick, in the order of nanoseconds, because we're doing this at 30 times per second. Right, so if we go and fly into something a minute. Oh yeah, I forgot this is broken in the editor. If I just hit disengage, it will fix it. Yeah, we're not going to have like orbital mechanics in the sense that slingshots will be a thing. We've been over that a few times, and basically the way I'm looking at it is that Kerbal exists. We don't need to be another Kerbal. What we're trying to achieve with this game, having proper orbital mechanics is kind of outside of the scope. We want to focus on the adventure of exploring the galaxy, not necessarily the orbital mechanics of exploring the galaxy. Sadly, no, we won't be doing that. Okay, so that's in centimeters because it's in unreal units. So the closest object is that planet, a radius of 8,360 kilometers, which looks about right. Yeah, 8361. 8360.5, so that's 8361, and the next closest thing is the star, which makes sense because we are in the innermost planet. Okay, yeah, that's fine. So the array sort is working, it's just not doing what it's supposed to. I'll leave that there for now. Potentially an SES. So this is like the final vision for the galaxy system. Right now, each star system is kind of locked in time, it's frozen in time. So all the planets have their orbits calculated, so all the orbits are correct and everything's all properly done, but they don't actually process, they don't move in their orbits, they're stuck in place. And the reason for that is there's going to be a lot of like infrastructure, like ships, moons, stations that need to be orbiting those planets, and we need to implement the ship getting captured in those locations. So once we have the system in place for the ship being able to automatically stay within a spherical orbit of an object and have it keep up with things like ships and stations if they're also in orbit, then we can look at moving the planets around the system as well, and have moons and things orbiting planets. Once you start actually moving the star system, it makes a lot of other stuff very difficult, because you have things like when the ship exits FTL, then everything's going to be moving. So you're going to have exited stationary next to a planet, and yet the planet and everything around the planet is moving at tens of kilometers per second. So you need to make sure that when the ship exits FTL, it itself is also moving relatively at tens of kilometers per second in the same direction as the thing that you've just appeared next to. Because what we don't want is to target a space station, exit FTL next to that space station, and then it's not there because it's already 10 kilometers away per second that you linger there. So there's a lot of stuff that needs to be solved in order to have everything moving like clockwork. So to begin with, it's all going to be stationary until like all the main game systems are done, and then we can go back and look at starting to move stuff. Because we also have to move all the NPC ships, all the physics states. Like if an NPC ship fires a projectile at you, then that projectile also needs to be moving tens of kilometers a second sideways in the orbit around that object. So adding that orbital movement just complicates everything to a massive amount. In the real world you would be, yes, but obviously within the game environment, someone's got to code that. It doesn't just work by magic. You actually need to physically program that in. And also the sensors as well. So if star systems are in motion, then obviously the thing you're targeting is moving. So you also need to make sure that when we're exiting FTL, we're taking into account where the object is now, not where it was when you first targeted it. So again, there's a lot of added complication once you start moving star systems around. A lot. Right. Hey Melissa, good to see you. So we've got a few issues here that are kind of detrimental to gameplay. And a lot of it's caused by the way things are updating and refreshing. So if we go to our short range mode, then this is refreshing once per second, because we need to capture things being in range and out of range passively as you fly around. So if we fly away from this planet, then passively that should disappear from the list because it's no longer in range. But we're updating that once per second, and if you look, it's causing a hitch once per second. In the editor mainly, it doesn't do this so much in a packaged game, but this is indicative of that happening and too much stuff refreshing all at once. So the reason everything is refreshing, including like that icy body over there, see that's also flashing once per second, because everything is being driven by the sensors updating. So every time this refreshes, everything else receives the update to say the sensors have just been updated, which is why all these things are flashing in space. So what we need to do is have a central location where we hold a ground truth for what is currently available on the sensors, and if it's just a display thing like we have on here, then we make sure that it's just this UI that's updating and not absolutely everything. So these things need not be refreshing, and the labels out the window need not be refreshing, just because this display here is refreshing. So we kind of need to break those dependencies and give them a little bit of independency. Yeah, we're not just adding FTL, we're actually calculating all the math for FTL as well. Yeah, the sensors, they have two modes. They have an active and a passive mode. So in passive mode, they're just refreshing to see if anything else is there. In active mode, they're actively performing scans. Should be the radius delta. So it's radius plus 10% basically. Yeah, I do want to add different visual effects for being at FTL that can be selected from and toggled. Just as a personal preference thing, including getting rid of the magic space clouds and just seeing stars drift past, which is what I'd probably do myself, to be perfectly honest. So just need to make sure we follow our breadcrumb trail here. Need to work out where I did the refresh because it was quite some time ago. It depends on which sensor mode. So I believe the long range was 2,000 light years. Medium range is basically half a light year because it's within a single star system. So if you're within that 1 light year cube, it will work. And then short range was, I think, 3 million kilometers. It says it there actually. Yeah, 3 million kilometers. So that's just updating the list item itself. Okay, yeah, so we are basically doing a full refresh of this. Just going through that. So we're checking our range. We are constructing our list item objects and then we're adding them to the list. So none of this is doing anything particularly bad in terms of performance. So those are just the list items. Okay. So none of that would be refreshing everything either. Yeah, we need to add a like a pending icon on some stars. So if you've already sort of queued up the exploration of that target, then yeah, you should have a little icon on the map to say that that one's already been actioned, to save you clicking on it twice. Hey, Sirius. The Magellan won't have escape pods, it will have life rafts, so more in keeping with an actual vessel. So on the underside, towards the front, there'll probably be 4 large life rafts, each probably capable of holding around 60 people, and they'll be equipped with just usual supplies, food, that sort of thing, blankets, and they'll be capable of landing. So they're essentially a self-contained landing craft, which is supposed to act as a survival shelter on the planetary surface. So what I'm looking for at the moment is where this is being called from. I'm assuming we've got a timer by a function by somewhere. Yeah, here. So it's going to be this one that's causing the issue, because it's the one that's polling once per second. That one, yeah, so that's just updating the visible list items. So literally all that's doing is updating the range to the ship, essentially, and not much else. It's going to be this one that's causing our issue. So we're gating it on sensor mode, and then the only thing we're doing is this, which is firing this. Now there shouldn't be anything here that's forcing an actual update of anything else, because they all react when broadcast our sensors data, so that is slightly confusing. Let's get rid of some of these tabs. We'll go through it a step at a time, trying to figure it out. It, we will get don't want that one, we want that one. Yeah, I'm the only dev. Technically, I'm not the only person working on the project, but I am the only dev. We've got Claire that handles practically all of the non-dev related stuff, and we've got a couple of contractors who dip in with things like the audio design and music. We're also currently talking to someone about a character system and all the animations and things. So hopefully, once we've sent them our requirements document, they'll be able to come back with a quote, and then we can decide whether or not to go with them in terms of completely overhauling our character system, which is sorely needed, because I think our character system is probably one of our weakest links at the moment, so it'd be good to get that done. I'm wondering actually whether it's this that's firing. Let's just double check that a minute. I'm not seeing any debug flash up for that. Okay, it's not that one then. This is one of the issues when you have such a modular setup. Is it's not obvious what comes from where all the time. So that's just rendering all the stuff in space. So it's not that. So it's definitely just the labels side of thing. Yeah, so it's probably this one. So it must be getting called, it must be forcing a sensors update, which is kind of what I suspected it would be doing. But let's just confirm that. Ultimately, this shouldn't be doing a sensors update, at least not on the short range. On its refresh, it should only be updating like when something actually changes. Yeah, I'm going with a funky paint job. Alright, okay, so there's our culprit. So you can see it's going sensors update once per second. Now the question is where is that coming from? So to follow the chain of events back. So we know that on our UI, once per second, it's running this full refresh, but we're not actually setting anything on our sensors data, because what it does is on the actual parent blueprint. Every time something changes, we do a set members on our live sensors data, and then that gets broadcast out as a global event through here. So we set the data, go blah 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 blah, set all the stuff, and then that gets sent out basically to any game system that wants it. Now the issue that we have, and where I'm going to start changing the way we do this, I'm basically going to reverse it so it works the other way around. Right now we are just broadcasting that out every time it changes. So that updates, we send it out to the game and say, right, if you care about the sensors data, something has changed. Here's the sensor state file. Now the problems that's causing is, one, that's all 4 sensor modes worth of data. So we need to split that into 4 to help reduce both the CPU overhead and the networking overhead, so that we're only transmitting a fourth of the data depending on which sensor mode you're on. And also, by having everything react to this, everything is being driven in terms of its update cadence by the sensors themselves, whereas really the sensors should exist as a source of data, not something that's driving the events on other systems on the ship. So this basically needs to sit there waiting to be read at whatever cadence a particular system needs. So whilst the UI is refreshing once per second, the holo-display, for example, might not need to, and the labels out the window certainly don't need to. So they can just be updating at a much lower cadence, or in an event-driven way. But this variable and its rep notify function is being triggered all over the place. Like, everything we do is setting that same variable and causing updates to go out. So what we need to track down is when we're on short range mode. Where is our mode switch hiding? Here it is. So this is our main button handler, and it's just, I'm not going to shan't click clear all because that will make it lag for ages. We basically take a button ID as the button that's been pressed, and then we work out what to do based on the 4 different sensor modes. So in this instance, we would have pressed the short range button. So the button ID would have been the short range button on the sensors. So that will come through, and that will be recognized by this. So mode short range would be the code. So those are all the different possible buttons that could be pressed. So what that does is it comes up here. It gets the data for the current system. So like whether you've scanned those planets and such. It sets this to short range, resets the actual range controls, and then goes through all of the child objects. Hang on, let's work out what's actually happening here, because it was a couple of years ago when I did this, and there is no hope of me remembering what I did a couple of years ago. Okay, so we're generating a list of distances Okay, yeah, we're populating distance to the ship for all of the objects within a star system for the purpose of listing them in order. I'll just get rid of some of these extra struct variables that we've added over time. Okay, yeah, so we're measuring distance to the ship, adding that to our array, and then for each of those, we're setting the range to 2 times the body radius, so that we can make the display fit the planet on it, on the holo display. And then ultimately we're setting that. Now nowhere here is it dealing with a timer. So unless I've got one running elsewhere. This will be it. Yeah, this will be exactly what's happening. So once per second, we are refreshing short range, but more importantly, we're setting that variable, which is triggering that global event, which broadcasts that out all over the place. So what we could do, because we can add a skip refresh, to stop it being broadcast, but we kind of still want it to do that. There's definitely a better way of doing this. Right, for now, let us just disconnect that. So what this is doing ultimately is it's going to stop it from constantly refreshing the short range sensors, but they are doing their own refresh independently of that. And what they won't be doing is calculating distance to the ship, because obviously the ship is moving, so we need to handle that at the UI end, not at kind of like the master sensors data end. So now you can see that our 1 second hitch is gone, and those targets are no longer flashing because we're no longer forcing the sensors to update. We've got our planet that's out the window there, but if we fly over to this planet and go back to our short range, I imagine what's going to happen now is this won't update. At least it shouldn't do, because it doesn't know where the ship is. Yeah, so our distance from the ship is no longer updating, and even though we're now out of range of that planet, it hasn't disappeared from our target list. So yeah, we're going to have to go on and make sure that these are independently working out their distance from the ship. And I think we'll probably do that on a per list item basis, and gate that behind it being visible on screen right now. I think there's a control for that. Yeah, so now we've approached that target, and we've still got the old one there. So we've fixed one problem with all the hitching, that's gone away now, and now we just need to make sure that our list items update. Okay, so on our short range update tick, not sure why we're doing that. I think what we'll do instead is we'll stop trying to drive this from the UI globally, and instead we'll do it from the list items individually. So we've got our distance value there. I'm hoping there's a is visible. Yeah. Although I'm not convinced that's the right one. Object list. I know you can get the ones that are visible from the UI itself. I'm just wondering whether we just lean in on this and maybe just refresh distances. Text distance. Where are we setting that? There. Okay, so okay, yeah, so that's what we want to be firing. So we should be able to drive that independently of the rest of it. So if we do, I suppose, where are we? Hang on, too many tabs. Let's get rid of some of this noise. So our short range tick, what are we doing there? So we've got a force. Yeah, so that's our distance update, and I think what we'll do is rather than forcing the ship details through, we'll get that instead. So are we setting that? That's just an object. Yes, we are. Yeah, so we can work this out live rather than pre-calculating it. So get ship state. So this should be all the details for our ship. And specifically, we want our local coordinates. So we can forget that. can use that macro instead, which means we don't have to we'll convert that one to centimeters, so we don't need to do that. So we'll take our local coordinates, I'll get our distance, so that will be in centimeters, and that needs to be centimeters. Did I not make that macro? No, apparently not. Okay, I'll add it on here then. Just a handy little helper function, just to, or macro rather. I think it was 100,000. Let me just double check that. Centimeters in kilometers. 100,000, yeah. So that will just do the conversion nice and quick. So now we're just working in centimeters rather than converting back and forth, which means we can do that. And that's another quick macro I made, which basically just takes a distance in centimeters and it will break it down to the different distance scales depending on its length in centimeters. Just a little handy macro just to make life a bit easier. Okay. Right, so on a per list item basis, that should be enough to put the range in there accurately without needing to grab that from anywhere else. Now I would make this update continuously on all of them, but if we're listing, say, 3,000 stars in the long range, obviously that's going to be quite unwieldy, so we're better off from the parent widget just doing this get displayed entry widgets, so that only updates the ones that are actually visible on screen, unless we can do like is displayed on here, which would be nice. No, I don't think we can. I still haven't got my head completely around these list items because I know they're virtualized, and I know that as you scroll up and down, it's kind of reusing the widget entries. And as such, you can have largely an infinite number of objects in a list, and it only ever renders the ones that are on screen. So it's not rendering everything that's off of the current visible list items. But I don't know whether that means they're not doing anything when they're not being rendered. I mean, maybe, I assume so, in which case we could hand responsibility over to each list item, stick a function on them that does this, and let them self-manage, which we could certainly do. But for now, we'll just stick with this. Oh, hey on it, Donnie, I missed you joining. Yes, always send Claire chocolate. That's the best way to get on her good side. Lots of chocolate. Right, let's just review again what we're doing with these. Because I have a feeling there might be some redundancy here. Okay, so our short range tick, that's refreshing the visible ones, so that's what we were looking at. Yeah, so force distance update doesn't require that anymore because we're just gathering that data elsewhere. Right, and that's just handling whether or not it has been selected. So if it's been selected, then that will refresh it, so it highlights. To be honest, I don't need to do that twice. That can literally just fire both functions. Actually, what's that one doing? That's doing it all anyway, so it's cleaning those up as I go. Yeah, that's kind of redundant because we're already doing that. I don't think... Hang on, let's see if we're actually doing distance only at any point. Okay, so that's only doing the distance. That's not... Okay, alright, we will keep the distance only one in. So that means... So if we're doing short range tick, yeah, and we're just doing distance only, okay. So what's this one doing? Okay, so what needs to happen is this distance calculation. So that should be handling things not being in range all on its own. Are we perhaps pausing that somewhere? Because is we're pausing these timers like immediately, so they should be unpaused when we're on short range mode. So galactic position pauses it correctly, long range pauses it, medium range pauses it, short range unpauses. Okay, we're also unpausing that one. Okay, so they're both definitely unpaused when we go to short range. So that's definitely running, which means that's definitely running. What are we doing here? Yes, we added moons, didn't we? So we're building up our list of system objects to include moons, basically at that point. I think what we'll do is we'll use that. But we'll do this after the fact because we want to make sure that because this is happening once per second and because we're using a temporary array, we can quite happily remove objects from the array if they are not within range. Or just skip them entirely, which is also doable. So rather than using this, we will get our ship state, because that is a better ground truth. Okay, so that's where the planet is, that's where the ship is. We get our distance. We convert that to kilometers. We deduct that from the radius of the object, and then we check to see is that within our 3 million kilometers. If it is, we can go ahead and add a list item. If it isn't, I think what we'll do is we will grab our temporary array and then we will remove that index. This array is recreated 1 second later anyway, so it doesn't cause any major issues. Let's just tidy this up a minute. After we've done that, then we can accurately determine how many objects are in range, because we've removed any that weren't in range. So that will just update the heading with accurate information. Okay, let's see what we get. Yes, Anasi, we will do an absolute magnitude based system where everything will generate with an absolute magnitude, and then we will compute apparent magnitude based on your distance to that star, and then we'll use that apparent magnitude to determine whether or not you can see it right now. But obviously, before we do that, we need to be able to hang on, let me just sort that out. Do that. Do that. That'll fix itself in a minute. This is only broken on the editor. It's not broken packaged. Can't work out why yet. But yeah, so we need to build a system that draws stars by distance, by magnitude, and we need the galaxy gen to support that as well. So right now we're building everything in 100 light year cubes, but because we're only doing a 3x3x3 grid, that means our maximum view distance is only 150 light years. So you can't render all known constellations with only 150 light years of view distance. You need something like 2000 light years to capture all of the stars that make up the known constellations. So there are two ways around it, really. We can bodge it for now by forcing the location of just those stars that make up the known constellations, or more long term, we can make it so that each class of star, as in each magnitude class, draws in much bigger cubes. So the O-class stars have 2000 light year cubes rather than 1000 light year cubes, 100 light year cubes, because in a 1000 cubed light year space, or 2000 cubed space, there's going to be very, very few O-class stars, and in some cases none. So there's very little overhead in doing that. Whereas if you try to draw how many M-class stars there were in that same space, you'd be looking at many hundreds of thousands. But there's a downside to that, because we are generating political states in the galaxy in those 100 light year cubes. So when we're adding life to the galaxy, and when we're determining whether it's like one empire or two empires at war or lots of independent worlds, we're defining that per 100 light year cube. So each sector essentially has a very different political state from the next, which means as you're exploring the galaxy, you're coming across all these different political states, all these different scenarios. In one sector you'll just find independent worlds, and the next sector along you'll find two big empires at war. So the galaxy will be different, everywhere you go. Now that only works if we're developing, or if we're generating the galaxy in those discrete 100 light year cubes. Once we start generating stars outside of those 100 light year cubes, then those stars cannot take part in the political state that we're defining. And furthermore, we might have overlaps with stars generating on top of each other unless we start tracking all stars in a long list and compare it against it every time we spawn a new star in. And right now we're only having to do that per cube. So having to do it with all stars obviously increases the overhead on top of that again. If we were just generating a galaxy and we weren't worried about generating complex political states, then it would be really easy to just do distance-based rendering based on magnitude. But because of those political states, we need to have a big think about how we do it. One solution could be that we generate all of the stars that are not included in the political situation first, and then we just do political space cubes independently of the rest of the galaxy. So essentially those star systems that are part of the political situation are added afterwards. So they're basically like an overlay state that goes on the galaxy, which basically it adds like a hard line between all the procedurally generated stuff and kind of the semi-manually placed political state relevant stuff. That would work, but if we do it that way, you will get inhabited worlds that have life on them, not FTL life, but just general life. It could be animal life, or at least like a tribalistic culture. You could get a culture like that spawning within the area of influence of a large empire, and that empire won't have touched that planet. They don't even know that they're there, because they're an overlay state that was added on top of the galaxy. So we just need to go through and look at all the different approaches to this, and pick the one that is kind of the best of both worlds, that gives us a 2,000 light year draw distance, whilst also maintaining discrete political states per sector. There's a solution there. We just need to refine it and pick the one that works best for us. Sorry, that was a long answer to a simple question, wasn't it? Hey Binary, good to see you. Yeah, the problem with any pre-baked stuff is it has to be referenced. Loading textures and parsing the data on textures is weirdly computationally intensive for some reason. It costs in the region of 20 to 30 milliseconds to load and process 1,000 by 1,000 pixel texture. Doesn't sound like a long time, but in game terms that's a lifetime. So if you can do it by math, you should do it by math, basically. So I think the octave-based approach to doing Galaxy Gen is the way it should be done. I think it's the way the Space Engine does it. I'm pretty sure it's the way Elite does it as well. So you're generating a lot of very bright stars very far away, and you're not generating M-class stars, or even worse, the like brown dwarfs, until essentially they're very, very close to you. So by separating out all those generation regions, it means we can drastically limit the amount of data that's being generated, whilst at the same time increasing our view distances. Because what we're doing is, and bearing in mind that M-class stars make up about 80% of the galaxy's mass, we're losing 80% of our data overhead by limiting the range of M-class stars and below. And the galaxy will still look bright and vibrant with all the other stars that are being drawn a lot further away. So it is kind of a best of both worlds approach. It's just those political states that are kind of the niggly bit. But we'll sort it out. We will have a solution, I'm sure. Yeah, again, we can't pre-generate anything because we've got not just the whole galaxy, but also the entire galactic halo as well. No amount of pre-generation is going to is going to work, because basically you're storing a huge amount of data. It has to be procedural to do the scale what we want to do. Doing it in octaves is the way to do it, because if O-class stars are only being generated in 2000 light year cubes, then the view distance for those will be 3000 light years, because you've got your, again, 3x3x3 grid, and you've basically got the central cube that you can see all of, and as you're moving to the edge of that cube, you can see halfway into the next cube. So if those cubes are 2000 light years wide, then in total, with the half of the next cube, you're going to go to 3000 light years worth of view distance. And again, for O-class stars, 2000 light years is nothing. There's going to be like a dozen of them at most. It's absolutely no data at all. And then as we go down through the stellar classes, as those stars become more numerous, then we make those cubes smaller and smaller, and obviously only generate them to a certain distance from the ship. And then when it comes to things like brown dwarfs, then you won't be rendering brown dwarfs 50 light years away, because they're so dim. And also things like rogue planets. You know, there's no practical way you could see a rogue planet 50 light years away, because they're virtually invisible. So it allows us to bake in numerousness for those dim stellar classes, whilst at the same time really pushing out our view distance for the brighter stars. Which kind of always reminds me of that point that every star you can see in the night sky is bigger and brighter than our sun, because of the way apparent magnitude works. So it's kind of crazy. Like when you look up there, every single star you can see is bigger than our sun, because anything the size of our sun, you wouldn't be able to see it in our sky from the distances that are involved, which is kind of a sobering thought. Sort of an ASCII. I think Elite could have that kind of data. I mean, their back end and server infrastructure is crazy. I mean, they have a tremendous amount of data that they crunch for their background sim. I think adding alien cultures to that would probably be fairly easy, in comparison to the amount of data they've got. I think it's more of a lore-based thing for them. We are indeed. We are very, very tiny. Okay, so after all that waffling, what we were doing is we were expecting this to update automatically. So we can see on the orrery map, obviously it's drawing the planet, but we're not detecting anything in range when reviewing that data. So interestingly, it does say 14 objects detected, which it probably shouldn't do. I wonder why it's consistently saying 14. If we push out that, yeah, interesting. Okay. So either we've got a unit mismatch going on here, or that is for some reason becoming invalid, but I doubt it because it's there. That's what we're referencing on the medium range. So unless, so we're clearing our temp array, which is good and fine. We're then looping the main array, which is this. So we're going through our satellite objects. So for each object in the system, we add the planet or star, and then if that has any moons, we go and add those too, which at the end of the day populates that with everything it needs to have. So system objects temp, and that's our working object that we then loop through. So that should contain everything we added there. So we should have good data for all of these. If we, I guess just as a test, if we ignore Boolean for a minute, that should list everything in the system on the short range sensors, regardless of how far from the ship it is. If it does, then we know it's probably a unit problem. Okay, yeah, so there's everything in the system, 28 objects, which is the same as we have on medium range. And then out of interest, if we just pick that moon, oops, send it to helm, and then we go there. We should see all of these numbers updating. Yeah, okay, so that's good. They're all updating without causing any hitching, which is good. And as we approach the moon, these numbers are going down because that's the planet we're approaching. So basically we need to do the same thing on here as well, so that this line, one scales the location of the marker, so that marker should be locked between the ship and the object unless it hits the edge of the display, and then it should always use the edge of the display as its distance measure, and it should be updating the same as these do. Okay, just zoom out from the moon. We should have its host planet just there. Okay. Alright then, so that bit's working. It's the range-based cutoff that isn't. Yeah, I was conserving energy. We're going to have to do some random debug spams on this to work out where this is failing. So to begin with, if we take our distance in kilometers, and then we can see what we're actually getting here, because if any of these numbers are less than 3 million, then we should be seeing them on the display. In fact, even more usefully than that, if we do it so that if it fails, we'll do that, and if it succeeds, we'll do that. So that we can verify that our distance values are in fact correct. Except that we want that one. I'd rather see it in kilometers. Right. Let's see what we end up with. Okay, so there should be 3 objects. Oh, there is. Ha, in range. Not sure why it says 15. That's weird. It's very weird, actually. That we're literally removing the indexes from the array, so how it thinks there's 15, I don't know. We'll approach that problem in a minute. So if we go to, say, that planet there, so we are constantly refreshing this list. Okay, good. So they are correctly gone. So when we get to the gas giant should come back and appear as an object. Oh, gas giant. Is this a range problem, maybe? I mean, it shouldn't be, because we're just capping to 3 million. Definitely in front of it. Okay, so this object here is most certainly less than 3 million away, being 95,000. Which begs the question, if it's 95,000, then how is that not returning true? Oh wait, because we're removing the body radius. let's include that. Then the body radius of that gas giant wasn't that big, so certainly not 3 million kilometers big. But I do wonder whether our approach distance was perhaps too big. Because the reason we're doing this is to get the distance to the surface of the object, not the center. So by deducting the radius from the distance, that gives you distance to the surface. YouTube is happy CSI, so I'm not sure what's going on there. Perhaps it's just me, perhaps I'm just stuttering. Okay, so yeah, so we're 31,000 kilometers away. We can see it there, we can see it out the window, we can't see it on there, and it's definitely less than 3 million on there. That has confused my brain, because how could that possibly return false when we're proving that that value is less than 3 million? That's impossible. Indeed. And also, if we are quite literally removing those indexes from the array, then how come it's reporting 14 when we're literally removing every index every second? That doesn't make sense either. Two mysteries. Okay, so if we let's stop reporting successes. Let's see if we can work out what's going on with this. I'm going to do the opposite of that macro, just to absolutely, definitely, completely check that we have the right conversion. And I'm pretty sure it was 00001. Although I will check with our length converter. So 1 kilometer is 100,000 centimeters, which means 1 centimeter is 0.00001 kilometers. No, point that. Just double checking. Which is what we've got there, but may as well use the macro. So we're definitely comparing the the post deducted value. That's definitely 3 million. Just out of pure curiosity, we add a couple of extra zeros to that, and we'll see whether that makes absolutely any difference at all. That will tell us if it's a math problem or a something else problem. Yeah, it is strange indeed. Oh, that's interesting. So hang on a minute. So that's where we are. And there are a bunch of moons. So we've got 4 moons, 5 million, 8 million, 15 million. Okay. 5, 8, 15, yeah, so it's the same moons. So if it's showing the moons, why is it not showing the gas giant? And what? Oh, that's from the star. Yeah, so 31,000 kilometers away. I wonder if it's the removing of the index. Let's just skip that a minute. Set that back to 3 million. Although clearly we're going to have to update our short range, because it's not including any of those gas giants moons, which we kind of want it to. Okay. So removing that array index, I think, is offset by 1 somewhere, which would be odd. Oh, I know what's happening. Okay, that makes sense actually. So when you remove an index from the array, of course you're then renumbering the array, aren't you? So for each subsequent array element, it now has a new index. So this index value is changing as we're removing items from it. So that was stupid. So we won't do that. What we will do instead is we will just do a count instead. Too many UI elements on this one. Just call it object count. We can reuse that elsewhere. Oops, no, we don't want it to be 64-bit. Yeah, I think the issue though is it's removing multiple indexes as we go. Because for each planet in the system that's not near the ship, it's removing that index, which means it keeps shunting the indexes back every time it removes one. So it would be cleaner to simply null this. And then for each one we add, we'll simply add one to that as we go. Okay, and then that is our object count. So we should have an accurate object count and things within range. But this is potentially way under what it needs to be. Let me just check Jupiter a minute. Jupiter's farthest moon. So Cori, or Core, however you pronounce that, orbits Jupiter at an average distance of roughly 24.2 million kilometers. It's a small 2 kilometer wide rock, basically. Yeah, and the farthest large object is 1.88 million kilometers. Yes, that's what I figured. So this 3 million kilometer range on the short range sensors is not enough to feature all the moons around a planet that you happen to be at. And I think we do want it to show all the moons. Maybe in its passive mode, and then maybe have an active scan range be significantly less than that. So you couldn't just sit at the gas giant scanning all of its moons 25 million kilometers away. You'd actually have to fly up to those moons. Okay, so if we say if we say 30 million as our short range, but then hang on, I'm having a think. So obviously the whole point of the short range sensors is that's where your maximum detail comes from. So we want that to be like flying up to the object. We don't want to do any short range scans from certainly not from outside visual range. Like basically, if you can see it, you can scan it. That's kind of how that needs to work. But obviously, the short range scan is also a surface scan, so we need to kind of be within range of that object. So we could do this actually with the radius value. So if we are within, and this makes this work with big stars, let's say within 4 times the radius of the object, which isn't super close, then that will scale with object radius. So basically, the smaller the object is, the closer you need to get to it in order to do the scan. Yeah, that should handle that relatively autonomously then. Because that basically then makes that independent of any set value. Let's just give that a quick try. And we really don't want to do any additional sensor modes, because we've already got 4 of them, and each of the 4 modes kind of has a purpose. So you've got where you are in the galaxy, you've got basic information about any system within 2,000 light years, you've got basically a high-level overview of everything in the system, including whether or not something is an Earth-like, so the actual final planet type, system-wide. And then this is the really specific, is there life on this planet? That's what you'd need the short range for, and to glean surface details. So if we're doing it 4 times radius, then let's just zoom out a little bit. That's basically kind of this kind of range. Radius at 1, so 1, 2, 3, 4. Yeah, so kind of there. So if you're within that distance of an object based on its radius, then you are able to do a short range scan. And that works as well for tiny star systems, because if we were to set like a hard 3 million kilometers, then on tiny star systems, like the whole system would be in range, which of course we don't want. So by basing it on object radius, that kind of keeps that under control. Okay, so as a test then, if we go over to that Earth analog, then we should see the gas giant disappear and the Earth analog appear. Okay, so gas giant is gone. And it also correctly says 0 objects detected, so that's good. Saw a moon whip past the window. Okay, there it is. So we're now within scanning range of that world. and it has indeed appeared. Yes, basically. So when it comes to like the huge number of moons that some of the gas giants have, we will put in what's the word for it? Non-regular, so irregular moons. So yes, small rocks and irregular objects orbiting around gas giants, definitely. Once the data structure is in place, then we could literally add every single moon that Jupiter has. But when it comes to like scanning gameplay, if we were to look at the medium range list, so we've got our Earth analog, and we'll indent these so that they're also indented. Only the major regular moons will need scanning. The irregular moons, and it'll probably say irregular moon on it, won't have any knowledge levels or anything associated with them, because they are essentially just a rock. And then when you click on them, it will just say, this is an irregular moon. You can scan it and get some composition, see what it's made of, but ultimately it won't be counted towards the overall system exploration. And the line in the sand that we're drawing for that is that hydrostatic equilibrium point. So if it's big enough to collapse into a sphere under its own gravity, then we're classing it as an object that must be scanned for full system completion, which is around about 800 kilometers in diameter. So basically, if it's less than 800 kilometers wide, you won't need to scan it. Yeah, yes, Jupiter has a lot. But also like Trojans and stuff. So we'll model the Trojans in as well. So that will also be for exoplanets. So we'll have Trojans in the orbits of gas giants and other planets. Again, those Trojans are probably so small as to be less than 800 kilometers. So they wouldn't be something that needed to be scanned as part of the overall system scan, but they'd be visible within the system just as a depth, just as a point of interest, really. They are something that you would expect to find, so they should be there. Okay, so hitching has been fixed. We've got no more hitching, no more flashy labels out the window. They're all fixed. No more flashy holo-display either. That's also fixed. Yeah, and that is updating correctly. All the numbers are updating. So let's just have a quick look at our issue list, because we can probably set a couple of these to resolve now. Yeah, so that one we'll tackle in a minute. Also, that should be working. I'll have a look at that too. Oh, I wish I could dark mode this. That's actually really bright. I'm sure I saw stuff flashing out the window. That's another one we'll fix in a minute. also that. So when we fix the approach distance, that will fix that too. We might have just fixed this. So on medium. So I'll have a quick look at this a minute, because what we just did should have fixed that, but it's probably because our function is specifically aimed at short range, so that one. If we call that display distance tick instead, or even more specifically, ship distance tick. And then we can also set that set for medium range as well. Just make sure that we update that to ship distance tick, and that short ship distance timer. So we can drive the update of all of the UIs with this. So if we do refresh, refresh medium, yeah, we're missing some stuff there. Is there already a refresh visible? Oh yeah, there, of course. Yeah, so if we do that, so we only want to refresh what we can see. Okay, so get displayed entry widgets. For each one of those, update on knowledge, update whether or not it has been targeted. We will skip that a minute because we weren't doing that anyway, so that's probably handled elsewhere. What we actually want to do is we want to do a distance, force distance update. Should sort that out. Let's just try it a minute on the medium range. Oh, Zephyr, thank you. Very much appreciated. and it is a pleasure. Let's just grab a random planet, tell them to go there, and on medium range we should see these numbers updating as we get going. Unless we're not unpausing this particular global event, looping event, even? No, it can't be. Alright, that's easily solved. So, medium range. Yeah, so oops. We want to unpause that, not pause it, because that is now relevant for this one. To be honest, we can do the same for the long range as well. There's no reason why this only has to be for the short range view. Yeah. So we'll only actually be pausing it for the GPS mode. And then if we do a similar thing on the long range, then we can force our update. Okay, so here's our refresh visible. So we just want this one. Okay, so yeah, we need a distance only Boolean on this. Otherwise, we're going to be doing a lot of refresh. Guess we'll stick that there. And then we can just duplicate that, do that. Okay, and then we don't need any of that or that. We can just do oh, this is a different class actually, so we do need to do a slightly different approach to this. So this is our star listing. So when we do distance, hang on, just get rid of those ones. Where's distance gone? There. Okay. we add so essentially we're going to stop doing what we were doing. Get off. I think replace that entirely. So update ship distance, and we'll make this just a standalone thing. So we'll get our ship state, we'll get our galactic coordinates this time for our ship, because we're dealing in light years now, and then we shall grab a copy of our sector location, where again we want our galactic coordinates, so we're going to do a distance to the vector there. So that's how far away we are in light years. And to be perfectly honest, we don't need to convert that format. So if we just do straight to text, actually, we want to make sure we're only going to 2 fractional digits. And then we'll format text on there. Oops. And then we'll do distance, plug that in, just put light years on the end. Okay, so that's now working largely independently of the data that we're setting. Obviously that doesn't need the distance variable anymore. So it still will be using distance to sort the array, but I think in some cases where we're setting that, we perhaps don't need to. And then all we need to do on here, where was it? That one is update ship distance. So for any widget that's currently on screen, we'll update the distance display. And then we just need to make sure we call refresh visible list items on here for long range. So refresh visible was it that? Refresh visible list items. Oh, right, yeah. And pop that in there just so that we've got that flag. Yeah, and that one will remain false for every other instance that we'll be calling it. Okay. So now the distance to the ship should be updating across all of the 3 main sensor modes in real time, and only the ones that are visibly displayed. In the long range Anasi, yes. Hey LT Gaming, good to see you. Yeah, it's also good, Zephyr, just for seeing the logic flow. Like looking at this, for example, like when you're just looking at the C++, it's difficult to see the flow of the logic of what's actually going on. It's just a bunch of function definitions, and you can't follow it like you could with like a flowchart. I guess that's why you make flowcharts when you're designing code documents. But when you're dealing with blueprints, like the logic flow is already a flowchart. So I find it so much easier to see what's going on visually in terms of the logic flow than looking at the raw C++, which is just a bunch of definitions. Granted, there are lots of performance reasons to use C++, but when it comes to certainly prototyping systems and understanding what you're doing, it's much harder to get confused with blueprints because you can literally see what's happening, which is why I like it. Right, so let's test the medium range one first. None of which are updating, that's not a good sign. Oh, I can use my test thing I did. Accelerate on should like put us there immediately. Well, that's that's placed us way further away than we want to be. Wow, and there are definitely no stars in range. We are tremendously far away from the Milky Way right now. In the blackness of intergalactic space. Let's fly back to Earth. Actually, let's do that, and do that, and yeah. We are stuck. They don't danger mouse, no, they're configurable independently. This was just me messing about, so you can change the screen colors to be anything you want, so like that. And then floors can be like that. Yeah, they're all completely independent of one another, including like the ceiling lights as well, so they're green now. And anywhere that I've implemented the ability to change color should change color. I usually go with something kind of did it the other way. I can't remember which way around I had it now. I think I had it around kind of that there and kind of that. I don't know, something like that. Yeah, it's you'll notice when you're changing the color wheel, they don't all change at once. I've got it staggered because if they all changed at once, it causes hitches. So you'll notice it kind of updating in a staggered way. And yes, we absolutely do need hex values in those, for sure. It's kind of funny actually. Like when you set the ship back to defaults, it immediately just looks really bland. It's like, it's so bland. So I might make the default values slightly more interesting. Maybe add a bit of color to them. Eventually, yes, it will be per deck and even per object. So we'll have the ability to paint individual wall panels because they already save things like health values. So it's no biggie to save a hex value along with that for the color. Yeah, so the panels can all be their own color, so you can go around with like a little spray paint thing, coloring them all in. Or just set them all the same color on a per deck basis. But we can't do the per panel coloring until we've added them all to the save structure. Because obviously if this panel here was all smashed and destroyed, then obviously we need to save that as part of the save game. So I'll add unique colors when we do that. Right, let's see if we can disengage. Right. Let's go visit Babylon 5. It was Epsilon Iridani, wasn't it, where Babylon 5 is? Can't remember now. Actually, let's go to a planet within that system. Indeed, CSI, indeed. Every wall panel, every carpet tile, it all needs to save. And every wire needs to save as well. Everything has a health value. So yeah, there's going to be a good 10,000 rows. Oh, hey Jonesy. What bit of the game am I most proud of? I think the galaxy. I've done a lot of research and a lot of trawling through like astrophysics papers to try and get my own head around the galaxy in order to code it. So yeah, absolutely, that's the thing that excites me most. Yeah, so these should all be updating in real time, in addition to updating as they move, which they're not currently. So let's see if we can sort that out. Yeah, it's definitely a game of two halves. It's, you know, it's basically a galaxy simulation and then a ship simulation, and then we're kind of just like merging the two together into a cohesive experience. Just make sure this is running on the different sensor modes. Yep, moons are in. Moons are in a basic way. So we only have regular moons. We don't have anything smaller than 800 kilometers. And they're not part of the actual save system for scanning or anything yet either. I put them in when Artemis was doing its thing, kind of in celebration of Artemis. So they're only partially implemented, but they are being spawned and you can see them. Have a good one, CSI. Sleep well. Right, so distance check is definitely firing there, and it's definitely firing there, and it's definitely firing there. Okay, so if we go to that random planet, except before we do, we need to fix the helm controls. I think that's a decent enough distance for the short range scan as well. You want it to be fairly big in the window. Okay, so oops. So knowing that that works, so refresh visible, distance only. Let's just make sure we're getting this far with it. So I suppose, actually, that is going to always report a static value until our galactic coordinates change? Because there is a conversion we need to do. So within a 1 light year cube, obviously the ship is in a position within that cube. So from one side of the cube to the other, that's an entire light year's worth of distance. So we need to take our galactic coordinates here, but also our local coordinates, and we need to convert this to centimeters, basically, within a light year, which sounds mental, and it is. But if we look at our flight system, where is it? There. And then we grab our autopilot. And here's one I prepared earlier. So we're taking what is half a light year in centimeters, which is a very big number. And we are basically mapping that range from 0.5 to minus 0.5, obviously with 0 in the middle of the 1 light year cube. And we're adding that onto our galactic coordinates to give us that decimal value, so that we have sub light year accuracy for distances. So basically just we need to use this on here, there, wherever it is, there. So our galactic coordinates that we're reporting over here actually, make a bit of room, needs to come from this. And then that is ultimately what we measure distance to. I mean, we could technically do the same for the object, but we'll measure it to the star for the long range. So basically, if we break that into its individual x, y, and z, get rid of that. And then similar over here. That's our x, y, and z. Right, that should give us our sub 1 light year cube values. And we might have an issue with flipped coordinates. So you'll notice that this one on the z-axis is flipped because of the way the galaxy's rotated 180 degrees, because we're moving space around the ship rather than the ship through space. It means everything's moving in the opposite direction that it would be. So when the ship moves forward, it's not the ship moving forward, it's the galaxy moving backwards. So everything's kind of upturned from that. We are having some issues with that in the coordinate space, which I need to fix. But hopefully that will be the right way around. So we should see sub light year values. Just fly over there. arrows to pick up speed. There we go. Yeah, so now we've got sub-light year values. Let's just see if we can get rid of some of that blurriness a minute. r.ngx.dlss.enable1. There we go. It's not quite as fuzzy now. Now we can potentially have this tick, maybe not quite so often. It's 10 times per second at the moment. That might be a little bit overkill. It does make it a little bit flickery. Let's make sure this one actually does count down properly all the way. Don't want it suddenly jumping up when we cross a boundary into the next light year cube. And it should stop at either 0.5 or 0 once we enter into the cube. See, it should be well within that cube now. Okay, now it's counting out properly because we're doing the location within the cube. It's able to work out the decimal, which is nice. I'm going to disengage the FTL so it's not broken next time we start the game. This is one of the things we need to fix with the NPC actually. When, as a player, you hit the disengage button, they can still control the throttle even though the buttons are greyed out, which means that the ship will never reach 0 and will not fully disengage. So it kind of gets stuck in a disengaging state because the NPC is artificially stopping it from stopping. So I need to remove their access to these buttons whilst the ship is disengaging. Bad NPC, bad. It's because he's Australian, that's why. Okay, that should have updated. What has it gone? Okay, no, that's good. And let's just try maybe setting that to 4 times per second. I was about even twice a second might be quick enough for the updates. Four times a second. It needs to be quick enough that it's obviously updating, but not so quick that the numbers become a blur. He did look a bit like Lex Luthor, you're right. Okay, so that's one thing fixed. Oh, actually, we had a thing we could close, didn't we? Yeah, so we can set this to resolved. Hurrah, hurrah. What build are we on now? Can't even remember now. 16 or 17? I can't remember. 17. I've put out a few builds over the past week, so I've kind of forgotten how far ahead we are. Right. Another bug resolved. Yeah, so let's see if we can sort out that ridiculously long number that keeps coming up on the holo-display. So essentially it's the target distance value. So that's just setting the root location for the material fade. That's just facing it to the camera. Okay, and then that's what we need to update. And I think what we'll do is we'll do exactly the same as what we did on here. We'll grab that because we can do the same update essentially. So this. Yeah, so this will run outside of a full refresh, which is what we want. Okay, that's just a target indicator. Right, and what we need to do when drawing the label, because we're setting the world location by getting our spline and basically picking a halfway point along the spline. So what we need to do is we need to check that distance, and if that distance is in excess of the radius of the display, then we need to use the radius of the display and halve that value instead, and that will make sure that the text is always like visible on screen. We'll fix that next, but for now let's just do the distance. Where's the distance? There it is. I think I'll collapse this. Yeah, we'll just collapse them into a box for now. So we're going to get rid of our ship's galactic coordinates and instead output that. So that should give us our sub light year value. Do the same for the nav as well. that a macro. Call that accurate ship position. Okay, and the same thing there, just to give it that accurate value. Right, so then we've got our locations to sort out on both of them. And we'll need to do this on the medium and short range as well. Just for good. Well, actually, no, we won't. Just the medium range, because the short range uses the same code. Right. So we've got that there. So that should be our distance in actual units. And yet the spline length, hang on. Okay, and I think that's in light years, so if that distance is greater than that, let me try and get my head around this, because the units might be different. So the spline length in this instance should be in light years. And then our long range is also in light years. So 200 centimeters in real terms divided by our current range is how many centimeters that is. So this also needs converting to this format, centimeters wise. Oh, actually, no, we might not need to, because... Oh no, we do need to, because that spline length, even though we've drawn it in light years, physically it's expressed as centimeters. So we need to know how many centimeters long it is. Obviously we're halving that, so we need to know, is the distance in centimeters greater than that in centimeters? So that should be the right comparison, and if it is, just do a select. Yeah, so if it's not greater, then we can just use that value. If it is greater, then it's going to be that times 0.5, because it's half the distance from the middle of the display to the edge of the display. Let's just try that a minute. And we'll do the same for the nav as well. I'll just check the sensors first. It should do, Darcy, yes. And I shall look into that first, as thank you. Right, so we haven't done that yet. So if we just pick something there. We should have a distance. Don't have a distance is concerning. Let's just see whether or not there was one to begin with. It's always good to verify whether it was broken before you thought you broke it. So there is our halfway along the line point there. So we need to do the math basically to fix it extending beyond the edge of the display. So if we pick that there, actually if we pick something miles away, and then we reduce the display, that range indicator there should be here. So regardless of how far out you go, as long as that's within view, it should be in the middle. And as soon as that circle goes out of view, then it should start using the middle of that instead. So we just need to work out where we're going wrong math-wise. It's probably this. Okay, so we're getting the distance in world space, which means we're using actual centimeters. So that's in centimeters then. So we're saying half of that in centimeters. So 200 centimeters divided by the current range in light years. I suppose that's going to give us a multiplier, not a distance. So we need to work out what the display range is in centimeters. Actually, no, perhaps we don't. Perhaps I'm overthinking this. Because, yeah, because if that's greater than 200 centimeters, then it's off of the screen, isn't it? So the distance then is going to be a flat 100. Yeah, because the edge of the display is 200 centimeters in radius. Half of that's 100. So if it's bigger than that, yeah. I tend to do this. I tend to like massively overthink a problem and then realize that it was actually really simple. I did that today. Claire was going through a maths GCSE problem with us for our daughter, and the question was like, what is p doubled or something like that, and I was like, well, how can you answer that unless you know the value of p? So then I was going through like the 4 different formulas that it gave you as an example, and it was like p equals 2r. So it was like, okay, but then there was also p equals 2 plus r. I was like, well, if r is 2, then 2 plus 2 is 4, therefore p is double 2 because it's 4. But then also p equals 2r is 2 times r. So if 2 times 2 is also 4, then both those answers are correct. And I was like completely massively overthinking the problem. And it wasn't asking for numbers, it was just asking for what is like a double. I was like, oh. Sometimes things just are simple. Okay, that's in the middle. So, does it stay in the middle? Oh, ish. Oh no, it does. Hurrah! Yeah, so that's steady in the middle until we get beyond that range. In which case it comes. Hang on, perhaps the display is. Okay, yeah, so it needs to be greater than 100, not greater than 200. So then it will go smoothly to the edge, and then it will stay locked in place. Alright, so that was pointless. I just needed to do that. So greater than 100, then lock it to 100. Yeah. Why did I make that so difficult? There we go. So right now, obviously SAJ is targeted, and that's 26,000 light years beyond the display, which is good. So if we zoom out there a bit, and we do the same test we did before, let's pick one that's kind of easy to see. That one will do. should go even further than that. Okay, so as we reduce range, it should stop. There we go. And it stays in the middle until the star is in range, and then it scales with the star. As does that. Okay. So the other problem, and I'm going to have to implement this on medium range as well, for good measure. But yeah, so on medium range, our distance is showing a crazy number. So we just need to figure out what is going on. So to begin with, we'll just do our quick fix on this. So that's greater than 100. Actually, it's an easier way of doing that, isn't there? Why don't we just clamp it? So it can never get further than half the display distance away. Not sure whether we started storing. Oh yeah, we did display radius. So to make it absolutely future-proof, is that defaulted to 200? Yeah. If we clamp the value at half the display radius, then it can never go beyond that halfway point. Okay, that sorts out that, and I suppose we'll do the same for long range as well. This is one of my favorite things about coding, by the way, is obviously this is probably the most efficient way of solving this problem, and yet this also works. But as much as that works, it's not the most efficient way of doing it. So there's always like this constant quest for the most efficient way of doing something. And I think that's the part of it I enjoy most. You know, identifying the most efficient, cost-effective way of achieving a goal. Now the question is, why is the distance all messed up? So obviously the orrery map is used for both long-range targets when you're looking at the overview, and medium range, or indeed short range. So the distance marker kind of needs to cater for that. But I think what we will do is we will ignore see that's wrong. This will be why that number is so massively inflated, because we're converting a centimeter value to centimeters, so we're timesing it by a huge amount. Yeah, 100,000. So we're timesing a centimeter value by 100,000 because that's already centimeters. So to begin with, that's already broken, and that needs to be our actual live ship state, which is coming from our game state. So that gives us our fully replicated current state of the ship, and it's also like an intelligent fetch as well, so it knows what ship you're on, so it's got like shuttle support baked into it. So when the macro runs, it checks player controller, looks at your current vessel, and will fetch the correct ship state from game states based on your current ship. So the reason I'm transitioning to using this is so that it doesn't matter what vessel you're on and what the display hardware that vessel's using, this will always report the right data for that vessel, which is going to save us a lot of heartache in the future, I'm sure. Right, so we've got our distance to our target in centimeters, and then really we just want our centimeter to distance macro, which we already created, which means none of that is needed at all, and we can just do that. And then and that's just sorting out the label. So if we do the same thing here, so we can get rid of that and that, pop that in there, except what we're going to do is we're going to get our local coordinates and our local nav target, and just get that distance. Actually, it's not local coordinates, is it? Because, hang on, yes it is. Orrery map, yeah. I will need to add into this whether or not we are on the long range overview mode. Don't know whether or not I'm doing that already somewhere. Don't think I am. Yeah, so I need to break out on that and work out whether or not we need to be looking at something outside of the current system. But for now, that should fix it. Let's fix it from within inside the current system. Oh, I can well believe it, Firstus. Yeah, that is a good feeling indeed. saving it, are we? There we go. Okay, so there's our distances. Interestingly, it's showing a nav target. Do we even have a nav target? Oh yeah, so we must already be targeting a system in this planet in this system, although it's not drawing the dotted line. I bet it does if I tell it to go there. Yeah. Okay, so the next thing is to make these update. Oh, they do update. Okay. Update less frequently, I think, to stop them being a blurry mess. Okay, so if we start doing that, there we go, then that value is still visible on the display. Okay, so the position and everything, including the numbers, they're updating at 30 frames a second. Now obviously, ideally we don't want those numbers to be updating 30 times per second. One, because it goes all blurry, but two, because it means we're having to calculate distances and do the spline work, do all of that at 30 times per second. So we kind of need a block, and I think we can do it with a time node. Does Unix time count up in seconds or milliseconds? Oh, it includes nanoseconds, so that's no good. Or does it? Oh no, it is seconds. Alright, so we can use Unix time then. So if we get now, and we do to Unix time, so I was supposed to do a double. Hang on, is that an int 64? Yeah, it is. Okay, well, that'll do. Then we can basically stop it. See, that's seconds though. No, that won't work. Forget it. Forget everything I just said. That won't work because that'll limit it to 1 second updates, which we don't want. So what we could do is outside of the holo-display, we can leave the spline work in as it is, but have the text update exist outside of this function as a separate thing, because the text objects already, they're not spawned dynamically, they exist as part of the blueprint. So we could just be updating those individually, and then we can bake in, you know, if that target's outside of the system, and add that to it too. But I shall leave it there, because that's just going to be messing with it for the sake of messing with it at that point. And then Claire will slap me if I do that. Although we will just check the long range one. I'm assuming, yeah, this also updates at 30 Hertz, so that should also count down quite quickly. And we're using the subsector position, so let's just let's make sure that it does before we draw a line under it. Then I can go and close those tickets. Yeah, good point. I shall check the helm as we go. Right, so if we pop over to ROS 128, we should see that update. And if we also, I don't know, select that as a target. Oops. Right, so we want to see both of those values changing as we go. Yeah, there we go. They're overlaid, I need to sort that out, but so 2.5, yeah. So 1.5, yeah. Possibly Delta. With half an hour to go, I can have a look at it. We have, when we press tab, we've got this little crown icon. I could put the little crown icon on top of systems that have a command action associated with them. To be honest, I could put the little crown on that as well, just for the lols. But yeah, that worked. So let's just close those bugs, and then I'll have a look at adding a crown to things that have stuff assigned to them. To be honest, that's going to help me debug the issue where sometimes they give up when chaining through different systems. Like they'll do the first couple, then just give up on life. So if there's still systems with crowns on them sitting there, then that kind of indicates there's a problem. Okay, so that one we should be able to resolve now. Oops. Fixed for 0.227.017. problem. We fixed that one. Let's open that in a new tab. To be fair, these are probably older bugs on the list because it's been like it a while. This one I will need to do a math review of because it's that whole doesn't quite know where within the 1 light year cube it is problem. So we'll leave that one for now. Oh, that's for them. Now we're looking at our oldest bugs. Come back to that one. I might have fixed that actually. I think that might be the same bug. So system labels flash, no they don't, not anymore. Yeah, that one is still a thing. I need to sort out drawing of the orbit lines, because if I cap the distance of the object to the display radius and you zoom out a bit too far, it completely deletes the orbit line, so I can't fix that bug until I've solved that problem. Yeah, so that's the one we just fixed. Yep, that's the same bug. Yeah, that's fixed now. So that's what we just added. with the automatic ticking display distance. I'll have to have a look at that because I'm not quite sure. That might not even be a bug. It's raised a while ago. That might be user error. I'll have to come back and double check that one. Yeah, I'll have to come back and review that properly as well. Okay, so that's a bunch of bugs fixed. So we're down to 125 bugs now. We had 131 when we started the stream, so that's gone down a bit. Okay, so the last thing we'll work on is if a star is currently the subject of a command order, then we'll put a little crown above it. Yeah, that makes my job easier for us. Oh, the stream just crashed. Yeah, I think we're back. Right. So when we are rendering stars, so this is that like giant spaghetti mess that we have for rendering the stars on the holo display. It looks worse than it is. Basically, we're just looping through all of the sector locations. Those are the one light year cubes that have something in them. And then for each class, we're just assigning instanced static meshes to them. And of course, they just need colors and things set up on them. So it's it looks messy, but it's reasonably straightforward. But what we need to do every time see, we can't rely on just adding targets because we only add those if we are less than 20 light years in view distance, because otherwise there'd be too many and it would lag like crazy. So we need to spawn, I guess, a tiny little UI above each star that has a command order associated with it. Might be worth doing that as a separate thing. So hang on, let's close all these tabs. That wasn't helpful. Right. So sensors long range. Right, so these are all the different things that we put on the display. So the stars themselves are just a small part of that. So in addition to the ship indicator, for example, it would be good to maybe do similar to what we did for rendering other ships. And instead of rendering other ships, instead we can render the target markers. So if we just grab basically all of that, pop it down there, so we're going to have to render this as probably a billboard. Are we doing this one as a billboard? I think we are, yeah. So we don't need that, but we are going to need that. So spawn object, no, spawn clap, that one. Actually, no, we don't want to add child component. No, billboard component, that's the one we want. Right, so that is billboard component object reference. So we just need to make sure this is the same billboard components. Billboard component object reference. Right, and then we should be able to add that to that type. Yeah, great. Right, so crown billboards. Let's reset the types on those. Okay, so we'll clear them all on every refresh, and then we're going to need a reference to our orders manager. So we're better off doing that on begin play, because we need to get all actors of class. In fact, we also need to do this. Listen for gameplay messages. Make sure that we're only doing this when all the levels are loaded. Otherwise, we can't be sure that the thing we're looking for is actually there. But if we absolutely check that first, then we know it will be there. So that's our orders. Oh, sorry, is it orders manager or task manager? I can never remember what I call it. Just going to double check the class just so that we're like absolutely sure that it's the right class. Yeah, task manager. Right, and then we know that there's only one of them, so we can cast to BP task manager, and we can promote that to a variable, which is our task manager. Great, so now we have a saved reference to the task manager, and it will wait until all the levels are loaded before it does that. So back to here, make sure I'm on the right bit. Yeah, there. So get task manager. Right, and then from here we can get I guess if we go with a ship-wide order, so get ship-wide orders, then for each of these we can grab our target, which gives us our galactic coordinates. So now, armed with our galactic coordinates, we can set our position based on that. So if we get rid of that and give it that, okay, so we're going to add our billboard there. Get rid of those. Okay, so we're going to attach that to our scene component so that it's in the right place. Then we are going to position that so it's in the right place. Won't worry about that for now. Won't worry about that for now either. Yeah, because that's just a text label which we don't care about. So all we need to care about is that, because we're literally just going to make a single texture billboard, and that's it. Okay. So I don't know how big this is going to be. It's probably going to be huge, but let's see. I don't want to use screen size scaling, otherwise it will stay the same size as you move about. Okay, so that system there, if we say explore that system, so that should have put a target above it. Let's just refresh the display. Okay, so I imagine the label has spawned. It's either really tiny or somewhere else. Oh, yeah. That didn't help. Let's make sure that scaling is all the same. Okay, yeah, so galactic coordinates times by that, we are spawning it in the 0 location, then we're attaching it to the components, then we're moving it, which is the right way around to do it. Then we're adding it to there. Then we're clearing that on every update. Add a test billboard just so we can get an idea for scale. Okay, it's a bit big. Let's try 0.05 to begin with. Yeah, we'll leave that one on the display just so we can verify that it's showing. And then on that one, I'll set the scale on here. 0.05. To be honest, that's probably a bit too big, but let's just make sure that it actually shows up. Not seeing anything there. I wonder if it's set to hidden in game. I think billboards are by default. So it's visible, hidden in game. Yeah, there we go. That was the problem. The fancier the better. Right, so we've got that one that's visible, so that's good. Size-wise, that probably is a bit too big. I reckon maybe half that size. But if we use that one there as a test again, so yeah, that worked. So it's in the right place. Obviously it's not the right size. Now if we cancel our ship-wide order, then yeah, it disappears, so that's good. I think it should be bigger. Okay, so the scale there is obviously not working. That's fine, it's probably, I'm going to want it from here anyway. So we do 0.025. I shall give that a try. I think we will add a little bit of height to it, just so it comes up above above the name of the star. So this should be in real units. So let's say we had 10 pixels, well, 10 centimeters in world space above it. Yeah, well, eventually, it would be good to have everything be configurable and changeable as desired. There we go. So now, as we're going around, we can see what we're looking at. So if we want to explore that system next. That was weird. Did I just click the wrong thing? Explore target system. Okay. Oh, I clicked cancel, didn't I? Yeah, there we go. I might put that over there, so it's not quite easy to click on. Right, there we go. So now we can see that those three systems are the target of future command activities. You know, I guess we'll do different icons for different purposes. I guess we'll come up with something a bit better than a crown for command. But at least it shows that those objects, you know, are being targeted for a reason. Yeah, and it persists that way as well. To be honest, there's probably a bunch of stuff we can do on here. Like if we have a billboard for, well, basically a copy of what you see here. Maybe not that one. Pick one we've explored. That one. Yeah, so these little 3-pip icons, I can make a billboard for all 3 versions, 1, 2 and 3, and then depending on the scan level of the star, we can add those to the display to show 1, 2 or 3 pips above each system, so you can see whether or not you've actually explored it or not. And because we're doing that separately from drawing the stars, it means we can actually pull that data separately, the same as we do for the breadcrumb trail and everything else. In fact, yeah, it's a separate data to the breadcrumb trail, but yeah, we can definitely do something with that. Let's just get rid of, is it that one? Yeah, that one. Get rid of that. Don't want that in our way. And there was one other thing I wanted to do, which was the breadcrumb trail. I just wanted to make it ever so slightly thinner. I felt it was a little bit fat on the display, a little bit overpowering. So if we make it a bit thinner. I'm also happy to receive feedback on like color of the breadcrumb trail. Obviously, I just picked red because it seemed like a good idea at the time. But you know, if you think there's a different color it should be, then I'm sure we can try variations and see which one suits best. You're welcome, Festus. It is a pleasure as always. Let's just make sure I didn't break anything. Alright, one last very small tweak. I don't like how low down that is. Give it an extra 5 units. Yeah, I went with red because it kind of stands out. I guess we don't want something that blends in too much. Well, that's clearly way too high, isn't it? I'll fiddle with that after the stream and make sure it's like sitting comfortably above the wording without being overpowering. I might actually also add it to the command target circle, so it's there anyway, and then when you click off of it, it kind of lingers if you're doing something with it. Great. It's nice to see the holo-display kind of evolving into something more usable. Okay, well, on that happy note, I shall leave it there. Yeah, it's going to be an issue of in various cases with lots of different icons on stuff. Like if we're putting the 3 green pips on things for showing exploration status, then obviously that's going to have to go to the left or the right of the crown. We're going to have to position them accordingly. And if there's a lot of them, then performance might suffer. So we might need to cap it to certain display ranges. But again, we'll see. We'll see how performance goes with that. Yes, this can potentially go out tonight. I will make sure that I haven't broken anything, and assuming that that is the case and it packages, then it can go out later. Maybe about 2 hours-ish before I go to bed, usually. Okay, well, I shall wish you all adieu, and I shall see you on Friday for more of the same. So have a great rest of the week, and I shall see you then. Bye for now.